Good morning, everyone, and welcome to the April meeting of the Mountain View Computer Users Group. I'm John Buono, the president, and I'd like to welcome you to what I hope is going to be a really amazing meeting. At least I hope so. Okay, there we go. So, any new members here today? I don't. Our sponsor for this month is our very own Carolyn McLean, the Candle Lady. And this month, her candles are amazing. Okay, if you're looking for a good gift to give someone, contact Carolyn. There's a number up there. Also, her email address, candle-lady@cox.net. Okay, today's agenda. Talk a little bit about business, tips and favorite applications, Tommy Tech Topics, question and answer, and then the presentation that everyone's been waiting for, the magic of the internet, which I hope by the time it is over, you'll all understand how the internet works and why sometimes it doesn't work and how incredibly complex it is. And the fact that it does work is, in fact, magic. This is our webpage. Go up and visit at least weekly. All kinds of good information up there. Here are the upcoming topics. Today is how the internet works. Next month is security best practices, password, passkey, and we will explain about passkey. Good. I get more questions. Just real simple. If you're given the opportunity to use a passkey to create one, do it. It is the single most secure way of accessing a site. It eliminates the need for a password. It is what should have happened years ago. Passkeys are good. They guarantee that someone cannot get into your system unless they are you. Okay.
Or have stolen your hardware.
No, even if they steal the hardware, because all passkeys except on the Mac have biometrics. And the Macs can support that too. Because on the what happens on the passkeys is on the Mac, it uses your phone to identify you.
Or your Touch ID.
Or your Touch ID. It uses some form of biometric to guarantee you're you. Okay. And then June, data recovery, maintenance, and backup best practices. We'll talk all about backups. Backups are your friend. Okay. Timely tech topics. What's been going on this past month? And we got some doozies. Okay. Artemis 2 crew took iPhone 17 Pros to the moon. Okay. They use them as a maintenance tool for all their manuals, tech manuals. They had them on their phone, which saved them hundreds of pounds. And they used them constantly when they weren't playing. Yeah.
I think they use them like for personal notes and observations.
Yeah.
And stuff like that.
The first iPhones went in near space in February 2011, which I did not know. iOS 26.4 was released.
10.1 this past week.
Pardon?
26.4.1 came out just a few days ago.
Oh!
And it was no security on that. It was all bug fixes.
Okay. 26.4 notifications improved, especially in focus modes, so that you don't get notifications you're not supposed to when you're in a focus mode. Apple Intelligence is improved in mail and notes. Primarily in summarizations, it's doing a much better job of that. Much better low-light photography, which was amazing to begin with.
Yeah.
Now it's ridiculous. In photos, it improved the duplicate detection, massive security updates, and that was the important one. If for no other reason, update to iOS 26.4 to protect against a really nasty virus out there.
And if your phone can't go to 26, check your software updates.
I'm coming to that. That's the next slide.
Sorry.
A much better battery performance. This I haven't noticed because I haven't had a problem with battery performance on my phones. Okay, Mac 26.4 was released pretty much the same as when iOS. However, there's better performance and stability improvements, faster page rendering in Safari, and once again, Apple Intelligence was improved. Much better USB and Bluetooth performance. That was key. 26. Previous, there was a sluggish response sometimes in USB, lagging, and Bluetooth performance. Apple discontinued the Mac Pro on March 30th. If your current PC works fine, keep it. Don't bother upgrading unless If it's a Windows machine that is more than 3 years old or a Mac that is more than 10 years old, you probably should consider upgrading. That doesn't mean you have to. If it's doing the job for you and you're not having any issues, don't upgrade. If everything's working fine, why bother? But if you're sitting waiting half an hour for the system to boot up, maybe you should upgrade. If you're getting a response, say 5 minutes between keystrokes, you may want to upgrade. Okay, security changes. This is the biggie. Dark Sword is a nasty virus out there. iOS 26.4 protects you against it. And for those of you who cannot upgrade to the 26 series, iOS 18 has been released so you can update to protect yourself against this. This is the first time Apple has really been concerned about a virus on the Mac series and iOS series.
And also, security updates all the way back to iOS.
Oh, really?
I did not know that.
What?
See, 18 was unusual because they stopped upgrading 18, hoping people would move to 26. You know, they've been out security updates to all the phones and the operating systems that couldn't support 18 or 26.
Mm-hmm.
This brought everybody in, but they didn't want to update to 26.
And to reiterate, shift from passwords to passkeys. Now, I get more calls weekly from people wanting to know about passkeys, which is good. That means more and more sites are supporting passkeys. I wish the government would. It takes me 20 minutes to log into the government sites.
I know, and they have 3 different ways of doing it now.
Oh, yeah.
And it still takes. Okay, moving right along. Windows 10 deadline. Support will be ending soon for Windows 10, much to the chagrin. Now, what does this mean to Windows users? Biggest problem is security updates. Now, depending on what you use your computer for, this may not be an issue. If you don't visit questionable sites, you don't have to worry about it. If you don't go on the internet at all on your computer, then you don't have to worry about it. Okay? If you don't use a computer, you don't have to worry about it. I knew exactly where you were going. This is a big change on Gmail, which I know a lot of you use. You no longer have to get a new account to change the name on your email address. They're finally allowing you to change your email address to something that makes more sense.
Yeah, like if you got your Gmail account in middle school and you spanked my butt, you don't want to change that.
Yeah.
But what does that mean? So you change your spank your butt, do you have to inform everybody?
No.
No.
If you had to create a new account, you would.
Yeah.
But now you can change the name of it and it automatically forwards the mail to you.
So
If they send the old
if it
address.
has the old address, you'll still get it. But
Has that been tested? I mean,
Yes.
you guys, I mean,
Yes.
no,
I know the
mine.
company probably tested, but
Still spank my butt.
Yeah.
No,
Yeah, I
just-
Like 7 or 8 email addresses on Gmail for various reasons. And so I went up and changed 3 of them, sent myself emails from the other accounts to see if I got them. After being confused for about an hour as to what was what, it actually worked. Okay, tips of the month. Oh, this is mine. How to use categories in Mac Mail. This is a cool feature in iOS 26. Let me go.
Question about the last thing.
Yes.
Does it require anything, like the age of the device?
No.
It requires nothing.
Well, it does require a computer. It does require you to log into Gmail, and it does require you to find where you change it. Okay.
Go to the settings and
So,
your account.
are there requirements? Are there hardware requirements? Absolutely not. Mail. Okay. Most of us are used to seeing our list of mail. Well, now there's an extra row of buttons up here, looks at the mail, and determines if it's personal, transactions. This one is called primary. I call it personal. Transactions, notifications, and promotions. So it now goes and looks, and This is the one I'm primarily concerned about, okay? This is
Everything.
transactions. Now, let's say that this one right down here, that shouldn't be in transactions. Well, let me go back over here. This one should not be here, it should be in transactions. So I can go down here to categorize sender and say,
Oh, it's marked as transactions.
it should be in transactions. Why did it show up a promotion? Shoot, I don't know. I can tell it what category I want it in because it's showing up in both.
Primary also, it'll go into primary even if it's categorized one of the other ways. If the Apple Mail, Jane, Apple Intelligence determines that they're a time.
Oh, I did not know that.
So like if you've got a limited time to respond to something, it'll put it in primary even if it's categorized as something else.
Okay, I did not know that about primary. This is all mail, so this way I can concentrate. Like I check this one about once a day. I check this one about once a day. This one, it's transactions and primary, I check about hourly. Yes, ma'am.
So is there a way to just check, to have everything show up in one place?
Yeah, right here. All mail.
Thank you.
And in the mail settings, you can turn off those categories.
Yeah, you can turn off the categories completely.
Just use it like it had been before.
But this is, to me, this makes mail so much easier to use because I'm not messing with mail I don't care about. Now, do I miss some things? Every day for sure. But things that are critical, I can focus on that and not go through all the junk mail I get.
So spam's not up there.
No, spam goes into junk.
So it's just assuming you don't want it. Because I know I find a lot of things in my spam that I want.
Right. And what you do is you right click and you say move to inbox. And that tells spam subroutine mail from this address is not spam, which works about 75% of the time. Any questions on mail categories? Okay, what's up next?
Is there a way other than that to, for example, I know that I received from one person, probably because of the way they title their emails, but I sometimes get their emails in mail, and other times that I find their email in spam.
Yes, you go in and make a rule, and you put that rule at the very top, so it's the first thing that's checked. The email from a particular addressee you put in a specific folder, and that solves that problem.
I just saw rules when you did that list,
Yeah.
so I didn't know that existed. Does that iOS particular, does my old device have that?
Oh, absolutely, yes. Rules have been on the Mac for ages in mail.
Well, here's a quick iOS tip. All the stuff that John just told you about Apple Mail and Mac works on iOS too.
Okay, now Mike is going to give us a presentation on network settings on Windows.
Hi there, I'm Mike McLean, and today I want to spend just a couple of minutes going over the Windows 11 network settings with you. And it's pretty easy to get to these. All you have to do is go to the Start menu, and we go to our settings buttons, the little gear. And on the left-hand side, you'll see Network and Internet. I'm going to go to that. And here are the network connections for my desktop computer. So let's take a look and see how we can configure these. Looking at the top, this lets me know I am at Network and Internet. And I'm connected by Wi-Fi. In my connection Fuzzy Bunny. Simply because, here's a little security tip. Don't use anything identifiable for your mobile Wi-Fi. You really don't want anybody to be able to figure out where exactly you're coming from or who you are. That can make you vulnerable. So I just use a kind of a random word, and I like Fuzzy Bunny. So I'm connected, that is, I've got a secured connection.
Bunny@gmail.com.
Properties, this is a private network, which is what I want for my internal network. And I'm connecting over the 5 gigahertz range. There are two primary ranges for wireless networks, 5 gigahertz and 2.4 gigahertz. And 2.4 gigahertz is the much more common one that's used, it's the older one. 5 gigahertz does not have nearly as much traffic on it with different devices. And if I click on this, a couple things I want you to notice is, first of all, up here, there's actually a network path. We started at network and internet, and I clicked to directly go to Fuzzy Bunny. Well, Fuzzy Bunny is actually located under Wi-Fi. And this is also clickable, so you can use this to navigate around the settings quite easily. So here's my Fuzzy Bunny properties. I can look at my network password from here, which I'm not going to show you. I've got this set to connect automatically when in range, which for a desktop system isn't all that important. It becomes much more relevant if you're using your laptop or mobile device and you want it to connect when you're in range. I have this set up for a private network because this is the network in my home. So your device is discoverable on the network. My other devices can find this desktop. If this is a mobile device and I was using it on public, I would connect to it. I would have it set up for public network, in which case most connections to this device is turned off. With private network, they're turned on because only your own devices should be able to see you. And we have where we can go in and configure our firewall and security settings. I'm not going to go there, there's not that much to look, it just lets me know that my firewall is on and my security settings are turned on. Metered connection, which doesn't really have that much relevance anymore. It was important back when we had dial-up and you were paying by the bit for your connections. Random hardware addresses. You can turn this on so that it would actually spoof the hardware address of your computer when you go off into the internet. Spoofing means it would provide a fake address, and it makes it a little harder for people to track you. I don't use that myself. I don't really get that any benefit from it. IP assignment, it automatically goes and gets an IP address for me, same with whatever DNS server that I'm using. And here's a little more information about it. My SSID, my wireless ID is Fuzzy Bunny. I'm using a Wi-Fi 6 or 802.11ax, that's the wireless protocol I'm using. Security, I'm using a WPA2 personal password, which is what you want. And then a little bit about the hardware that it's using. 5 gigahertz, the aggregated speed is 1,201 megabits per second. Essentially, that means it's a gigabit connection. IPv6 address, here's my IP address, IP version 4, which is an internal address. And talking about that is a little bit beyond the scope of this. Well, we'll probably talk about that a little bit later. And here's the physical address of my network adapter. I can go to advanced Wi-Fi network properties from here. And this brings up the old interface from Windows. Again, I'll connect automatically when this network's in range. And I can set my password here. Encryption type is AES, security type is WPA2 personal, that's what you want. And advanced settings doesn't bring you much of anything, just enable fixed components for this network, nothing we need to be concerned about. Okay, I am going to go back to network and internet. Data usage. This lets me know over the last month I've used about 7 gigs of data. And this lets me know exactly how much I've done. Looks like Adobe, when it updated, used 2.5 gigabits. Windows updates have used a couple, and then it goes down from here. So you can see exactly which apps you're using that are transmitting data over the internet. I'm going to go back to advanced network settings. You'll see that this took me under advanced network settings for data usage. If I click on the little 3 here, I can go all the way back to network and internet, which I'll do that right now. Okay, here's the things I can look at. Wi-Fi, I do have it turned on. I can turn it off if I wanted to. And if I click on that, this takes me again to the Wi-Fi settings. Here's the Fuzzy Bunny properties, which we just looked at. Again, you see this takes me automatically that way. I'm going to go back one. Show available networks. I'm connected to Fuzzy Bunny. This is my network. This is what I want. But this also shows me the networks that I can pick up in my neighborhood. These are my neighbors that they're broadcasting. Okay, manage known networks. Here's something I really wanted to let you know about, because managed neural networks lets you look at all the networks that your device has detected. Now, not that important on a desktop computer like this one. It's picked up that Sneaky Ferret, that is a router that I use when I travel, and I've connected it up to this to test it, so it knows about that one. It knows about my phone if I use that for a hotspot, and it knows about Sleepy Weasel, which is another travel network that I've used, and of course Fuzzy Bunny. Again, not that big of a deal for a desktop system. However, if you travel and you use your laptop to connect to hotels, you might want to check this out. When I first found out about this, I looked at my laptop, and I must have had 100 different networks from different hotels and places that I've stayed at that were all in here. And they'll stay here permanently until you tell it to forget. So, just something to know about. It's also a good thing to check out for security to see if your device is connected to a network you didn't know about, just in case another security thing, just in case somebody unknown to you got into your system. I'm going to go back to Wi-Fi. Hardware properties, here's the information about the actual hardware adapter. We looked at some of this earlier. And we get random hardware addresses, which we just looked at a little bit. And that is, down here, that's all for the Wi-Fi. Then we have the Ethernet. I do have an Ethernet connection on this computer that I'm not using. So if I wanted to plug an Ethernet cable directly into my router, I could do that and turn this on. Right now it's not connected, so it doesn't really give me any information. VPN, I can control a VPN from here, a virtual private network. I don't have one here, so I'm not using this for anything. Again, something that's not really that important for a desktop computer, but I could turn this into a mobile hotspot. If I wanted to, I'd turn this on and I could show my internet connection to another device. Airplane mode, again, not really important for a desktop system, important if you've got a mobile device and you're using it while you're traveling. And then a proxy server, which is something that's been around forever. If you wanted to set up a internal server in your network, most people don't do that anymore, or use a dial-up connection. And advanced network settings, here is all the things that you can see at once. Again, Ethernet, the Wi-Fi connection, Bluetooth network connection. You can actually use Bluetooth to create a small internal connection if you wanted to. More settings, advanced sharing settings. And here's where I can set up private networks and public networks. Again, you're probably going to want to use a private network for most things. Private networks, network discovery is on, and I'll set up network connected devices automatically, and I've got file and print sharing turned on. A public network, that's all turned off, so you can't be seen by other people when you're out there on a public network. All networks, they can set up for password protected sharing, so that anybody on my network, that would be Carolyn, would have to do a password if she wanted to use something like shared files printers. She'd be really mad at me if I set up a password user printer, so I'm not going to do that. And advanced network settings, again, data usage, hardware connection properties, which we've looked at, and network reset. This is a fast way that I can reset. If I'm having problems with my network, I do a reset here. And this will basically restart the PC, and that will definitely reset everything. And from here I can go to Windows Firewall and Internet Options. I'm using defaults on all those, so we're all good. And then of course help information if we needed that. And back to network and internet, and that is everything from that. So that's where your network and internet connections are when you're on your Windows 11 computer. I hope this is helpful, and I'll see you later.
The good news is it rarely do you have to mess with that unless you're traveling a lot. Once you set it up in your home, you never have to worry about it. So you do something to change it, like adding a VPN or taking off a VPN, getting a new router. As complicated as it seems, it really is not that complicated. Most of it's automatic. You just need to know it's there if you have to do something. A stroll through network settings. Barry's doing the same thing. but on a Mac this time.
Hi, this is Barry Midgordon, and this is your Baz Mac Geek tip. Let's take a stroll through macOS system settings for networking. You can launch system settings from the dock here. If you don't have it in your dock, you can go to the Apple menu and choose system settings. Either one will work. That brings up the main system settings window, and you'll see in the left sidebar near the top, right underneath your Apple account information, the settings that we're going to be checking. Wi-Fi is on the top, mainly because it's the most common used way of connecting to a local area network. But there's also, two down, a setting category for network. And this is where you would access all of the various different network settings available for your Macintosh. I'm using my main desktop Mac for this. It's a Mac Mini, an M4. This desktop computer has a number of different ports, different kinds of connections that you can make for networking. It lists them here. If you have a laptop that's not a MacBook Pro, you won't see, for instance, this Ethernet setting right here because it doesn't have an Ethernet port. We can see at the top here what's connected and what's active in this setting category. Wi-Fi. As I mentioned, it's the most common way of connecting your Mac to a network. Click on that item in the list and it gives you the details of this type of connection. It tells you the network you're connected to. My ISP assigned this particular SSID to our home network. I didn't have control over it. They put my name in it. It's not recommended to do that if you have control over the router in order to create the network name, or if your ISP gives you control to change it after the fact, which I don't have. It does tell me it's a secure locked network. I got good signal strength, and I can get some details here on this particular network. Pops up an overlay. It allows me to turn on automatically joining or not. And since this is my desktop computer and it's in my home, it doesn't move, I have it turned on because it's the only way this computer connects to the network and the internet. It has a private Wi-Fi address setting here. You can leave this fixed or you can rotate it or turn it off. You can see that this setting helps reduce tracking of your Mac by Wi-Fi network operators. Low data mode helps reduce your Mac's data usage over specific Wi-Fi networks you select. This you might want to turn on a laptop computer when you're traveling and you're using a hotspot or some other connection that they have metered or limited bandwidth. And limit IP address tracking is turned on as one of Apple's privacy features. I suggest turning that on any network you happen to be connecting your Mac to. And at the bottom, you can tell your Mac to forget this network, which means it won't remember the credentials to log in, and you'll have to input them again if you want to reconnect to that network. Before we leave this, we can look at some other categories regarding this network. You can get the TCP/IP information, DNS. This is where you would set up DNS servers for your device if you want them different than what your router's providing. I have a couple in here that are privacy related. And these other groups of settings are items which I suggest you just leave on the default. No need to play around with them unless you are a networking guru and know what you're doing. Okay, let's look at some other things here. Other items under Wi-Fi. I have a personal hotspot available if I want to use my phone, which occasionally I even do here in the house when our regular ISPs, our internet connection is unstable. List known networks. I have no other networks that this computer knows about. Down at the bottom, we have ask to join networks. If it senses another network, it will notify me and ask if I want to join it. I can actually turn this off since there's no other networks I want to use here. Might as well turn ask to known networks off. Ask to join hotspots. Ask to join. I have that set to ask to join. If I lose an internet connection on the regular Wi-Fi, then it'll ask me if I want to join the hotspot. And sometimes it even picks up my wife's iPhone hotspot and asks if I want to join that one. Under advanced, we now have a list of known networks, and these are actually networks that my mobile computer had joined. It just knew about them. Require administrator authorization to change networks. I don't need to turn that on. I don't need to put in my password every time I want to change networks. Or to turn Wi-Fi on or off. I don't want to do that either. Show legacy networks and options. I don't need to see that. And this also gives me my Wi-Fi MAC address, machine access code. I think that's what that stands for. And we're done. Let's go back to the main network settings and we can look at other options here. Apple puts the firewall, the built-in software firewall, in network settings. It's active. There's not much to see here. It just has an on-off switch to use the firewall. It doesn't impact the performance of your Mac hardly at all, so I suggest any Macintosh turn that on. You can look at all these incoming connections here and change them granularly based on application and or service, or you can block everything. With the firewall on, it's pretty safe, so I'll just leave that at the defaults. Other services under networking. You'll see these here. As I mentioned, Ethernet is here because I do have an Ethernet port on this Mac, but it is not connected. If it was connected, I could even make it inactive in this section. But since it's not connected, no reason to turn it off. I could also use the iPhone via USB, and it would use the iPhone's internet connection and pipe it through a USB cable. It says it's attached. That's because I'm using my iPhone as a webcam. So I do have it attached to USB to this computer, but I'm not using the network connection. And then because this Mac Mini has a Thunderbolt port, I could plug in Ethernet via that Thunderbolt port. I also have a Thunderbolt, it says bridge, it's a Thunderbolt dock connected to this Mac Mini, and I could also plug in Ethernet or some other connection to the internet through that, and that's why that's there too. Now these are the settings in macOS 26 Tahoe. If you are using an earlier version of macOS, you will see basically these same kinds of settings. Ever since they changed the System Preferences app to be System Settings. If you have an older Mac and you still have System Preferences instead of System Settings, the entire GUI of this will be different. So that's a quick tour through the network settings for macOS. Hope this was helpful. We'll see you next time.
Okay, one quick thing that came to my mind as I was watching this. I do not know if Android supports this. I do know the iPhone supports this. Let's say somebody's coming over to your house, visiting a friend. They want internet access. Well, you don't have to give them the password. As soon as they try to log into your network, you are alerted on your phone that this person is attempting to get internet access, and allows you to log them in. And from that point on, anytime they come into your home, they'll automatically have network access without them having to do anything. It's really a slip so that you can give someone, and especially if someone is trying to log into your network, you're alerted to that fact.
I think that's the key. I don't think it matters what kind of devices, if the device starts, your iOS or even your Mac will see that somebody's trying to get on your network.
I don't know if it works other than, I haven't tried it. because I don't know anybody who owns Androids. But I don't know if that feature is available on an Android.
Oh, I
If-
see what
yeah,
you mean.
yeah.
For the phone, yeah.
Okay, share a favorite. I've got one, just came to mind. Down here in my dock, you'll see some funny icons. Like here, I have an Amazon application icon on my Mac. For many of you, you may not say, hold it. There's no application for Amazon on the Mac. How do you have that in your dock? What happens if I click on it? Son of a gun. That's an Amazon application. Where'd that come from? This is a feature of Safari, and Safari is the only one I know of that does it. When you go into Safari and you're on a site, so I'm up at our site and I can go over now, down here under File, Add to Dock. This takes any site that you are on, turns it into an application and puts it in the dock. So sites that you visit regularly, now it's one click away. Like I'll show you the other one that I have is for YouTube, because I'm up on YouTube constantly. I just click on the YouTube application, John Buono's YouTube. It's my own application.
Could you say again how you get to the add to dock? Is that settings or?
File, Add to Dock. The same thing on your iPhone. Yes, you can save to home screen, and it creates.
I think it says add to home.
Yeah, add to home screen. It creates a button that it
Where
puts.
do you start? Where do you get it? Oh, you're on
You go to the
the,
site.
You're in Safari
You're on Safari and you're on the.
on a site that you want to.
website.
Yes, and you go down to the three dot button.
The what dot button?
The three dot button down at the bottom of the screen, and one of the options you'll see is Add to Home Screen. That creates the application. Yes, sir.
So you're saying if you have an iPhone and you can get to the internet, but you don't necessarily have that particular app on your phone, once you get to that website, you click on add to dock, add to home, whatever.
Absolutely.
And it creates a slim, skinny version of an app such that you can get the functionality.
Absolutely.
But
Yes.
that means that since you don't have the official full-blown app, you can save more space on your phone because you don't have 30,000 apps.
Yes and no. Most of the time, the actual applications, will have more features than just the website.
Okay.
Right.
But I can tell you, there's a lot of companies out there that are publishing applications that are nothing more than this, a web browser. Yeah, because it looks just like an application. We'll add this one to the dock down here. I can even rename it, which I'm going to do because that name's too long.
Okay, I just tried to do it on my phone and I can't find it.
Well, it's not quite, it's a little bit,
Barry, do you want to mirror over to me?
Yeah, I was.
Now I have a button in my dock, click on it, and I now have an app. And acts just like an app, which is, to me, that's a great reason just to buy an iPhone. For that feature alone, works.
all right, so I'm on the webpage, on our webpage, in Safari, on the iPhone, and like John said, tap the three dots bottom right. It doesn't have an add to home screen right here, you have to tap share first. And then the bottom right again, for view more, and scroll up, and then there's add to home.
It's well hidden.
Yeah,
Would you do it one more time?
yeah, I'm on the webpage, and it's got the three dot more menu, and then share. So on the older versions of MacOS or iOS, look for the share.
There's nothing.
Yeah, I was looking at Maureen's got an older version of iOS running. The Safari page she's on, there's no like Chrome that has Safari buttons. I don't know why.
That's weird.
Yeah. So anyway, once you go to share, then view more, scroll up, find add to home screen. And again, you can name it and open as a web app. That's the one. I'll add it. Just gives it. Now, there's a way of customizing that. Load that icon.
The
favicon. Yeah.
the favicon out.
Favicon.
Yeah.
However you pronounce it.
I have no idea. Any questions?
Oh,
It
on
works
this
on-
or
yeah.
other one?
No, just on this. We're almost to our first Q&A. That was one favorite.
I have a
Barry's.
very short favorite. I've just been enjoying our return to the moon this week, or this last 3 weeks.
Is there any narration?
And some spectacular photography. The tools they have for this, as opposed to 54 years ago.
And all the room in that capsule?
Oh, I know.
It's
It's designed
jeez.
for 6 astronauts to be, yeah, and they just had 4 for this trip. But did you watch the splashdown yesterday?
No, I
Yeah.
didn't.
When they recover, when they
once they're in the water and they got all the floats and stuff around it, the diving team, they send a person, a medical, Navy doctor, into the capsule, one per astronaut. So there was 8 people in that capsule before they started bringing the astronauts out of it. It's got a lot of room in it compared to Apollo.
I remember when the poor astronaut, couldn't even move in the capsule.
Anyway, so
Okay.
Where did you get those pictures?
off of NASA's website, go to nasa.gov, and all of their photos, because it's a .gov, it's all public domain. Anybody can download them, use them, whatever you want.
And now for what many of you have been waiting for, patiently, the question and answers. Who's got a question?
Oh, I do.
Yes.
Okay, I am purchasing a new phone and a laptop. I'm gonna buy refurbished. I know, right? She held out.
I think I'm gonna have a heart attack.
I'm aiming for a 16. I think that's from what I've looked into, a 15 plus and a 16 are two of the better choices. Do
Yeah.
you guys agree?
At 16, yes.
Depends. Yeah. I don't know how much a refurbished 16. If you're just going to get a plain 16, you're going to look at the Pro or Pro Max.
I'm considering, because here's the thing.
Because the 17E is going to be probably just as good as just a regular 16, and it's going to be cheaper, even though it's not refurbished.
Okay, the way I would like to be able to use my phone, that I need to buy a new phone, is with our business. I can't load websites. Because I can't get to the iOS that it supports, that it needs to support it.
Oh, I see.
So I will be probably using it, like to get to website, to get to create maybe on Canva. I'm even considering a little bigger phone rather than as small as this one is. That's why I'm open to potentially spending a little more and getting a middle range. This is a 128 gigabyte storage. I'm considering doing the 256 in order to be able to store files and
Absolutely.
and photos and videos on. I want to use it to create video. So that, I think I've said enough to say, does that sound like, well, Barry, I heard you on the 16, the 17, potentially serving me better.
The 17E, which just came out.
Why an E? Isn't an E
That's
smaller?
the E is the new entry-level iPhone. And if you don't have a need for like multiple camera lens kind of photography,
Okay.
it's just
Yeah, I
a
don't
single,
care about
it's a
photography.
single
I don't
lens.
think.
I mean, it's computational photography is great anyway.
Right.
It's probably a better deal than buying a plain 16 because you're getting this year's technology rather than last year's technology.
What I'd also consider is physically holding them
Yeah.
to see how it feels in your hand. That is just as important, if not more important, than anything else. The 17E may be just the right size, it may be too small, or it may be too big.
Yeah, it's like size-wise, it's slightly bigger than just the regular 17.
Yeah, but for what you want,
It's not a small phone.
yeah, but 17E is a very good consideration.
Then similar with the laptop, I'm looking at maybe 23 as far as the year goes, and I'm considering 15-inch.
15 inch is a good size. Personally, I would go for something 24 or later. 23 wasn't a bad machine.
You've got Intel Max right now, right?
Probably.
Yeah,
So any Apple Silicon's going to be a big
Upgrade.
boost. But
yeah,
I would go at least.
because 23 is still
I would
Intel.
get an M3 at the oldest.
Yeah. I would make sure
What?
Apple Silicon, make sure the chip is one of the M series chips.
M3 instead, because we're on the M5 now. But I would go. I would jump to an M3 and not an M1.
I think what I was looking at was M3. I
Okay.
remember seeing M3 and going, what's that?
That's the processor. And you will see a significant change in speed.
Okay.
I mean, lightning. Okay?
Right now in the refurb store, the 16 Plus is the only 16 level available. And the cheapest configuration is $700. 17E is $600.
We just saved you $100. See, that paid for your membership.
Okay, now I have one more question.
Okay.
Related to this, all of this. Visible is my phone plan, is a resource for getting a phone. Swappa, do you guys know swappa.com?
I heard that.
It's another refurbished, Apple refurbished Simutech in Tucson is another resource I'm considering. And then
Oh, yeah.
Back, I can't remember the name of this one, it's Back something, that I was considering. Do you guys have any other resources for purchasing refurbished?
Occasionally, Best Buy has refurbished ones.
Well, I was thinking of going to Best Buy today to see what they had.
I personally would use the Apple refurb
Yeah.
because that is a 100% guarantee.
It's like buying new in terms of the warranty.
Apple?
Yes,
What about Simutech?
I don't know.
Because we
They
had,
would give you good support, but it means probably going there. if you
yeah,
need
well,
to.
same with Apple.
Well, you could do Apple over the internet. In fact, they
Oh.
encourage you to do that way,
Okay.
because if you go to the Apple store, they don't, depends on what service you need, but if there's hardware repair that needs to be done, they don't do them in the stores much anymore.
It's
They will send
shipping.
it off, and it'll take longer to go through the store than if you go direct through the Apple support page.
okay. Also, you just made me think of the question, are the older, Apple, the paid Apple support?
Apple Care.
Apple Care.
Apple Care.
Yeah.
I haven't had it in so long, I forgot what it was called. The Apple Care, is that usable, viable with a used device?
If you buy from Apple.
If you buy from Apple, you can
yes,
get
you
Apple
can get the Apple Care. Actually, I think you can add it to just about anything. I mean, they'll take your money monthly for an extended warranty. Depends on it. Well, on really old hardware they're already classifying as either
Like my 7.
legacy
They're not.
or unsupported anymore, then they won't. But yeah,
Okay. So what's the benefit of Apple?
if you buy Apple refurbished,
Yeah.
When they refurbish return hardware, they completely go through it and repair or replace anything that needs to be done. And in terms of the phone, you're going to get a brand new battery. It's going to have a brand new case if it has scratches and stuff, a new screen, whatever needs to be done. And you get the same warranty and guarantees in terms of that life of that phone as if you were buying it new from Apple. But the new products from Apple, their quality control is coming off the assembly line and going directly to you. It doesn't have somebody minutely going through every single component, making sure it's going to work right before they give it to you.
Like the
So you're actually getting better quality control over a refurbished product from Apple than you would a brand new one.
And you're guaranteed to have all Apple parts.
Yeah.
If somebody else refurbishes it, except in the case of Simutech, because they're an authorized Apple dealer, that you may get third-party parts that may not work well.
Okay.
So my personal opinion, I think Ari supports it, is refurbed is the way to go from Apple.
Use Apple if you want to buy a refurbished Apple product.
Yes.
Yeah. I bought my Mac Mini that way. 10 to 15% off of the retail price. So it's not a big discount. It's a little bit.
Yep.
And you get the just service as you would. Same.
Best Buy sells refurbed,
Apple products.
Yeah, they do. Yeah.
From Apple.
Okay.
and sometimes they'll discount them quite a bit.
Looks like the newest phone that Swappa has right now is a 14 Pro.
Okay. Yeah, I was
So
looking at
that's
that
not
last
that's
night.
not going to provide. It's going to provide the latest operating system, but not Apple Intel.
I would go with the 17E.
Well, no, I'm hearing, I'm at this point, I'm not considering really before 16 because of
Yeah.
age.
Yeah.
Yeah.
And going back to the laptop, because we didn't really touch on anything with the laptop. With what I've described is the way I want to use it, am I likely to want the 8 terabyte? I think that's just wild. You go from like these little terabyte, 256, 1, 2, 3, 4,
You're gonna
and
pay-
8.
You're going to pay $400 or $500 for 8 terabytes of internal storage. What are you doing? Are you doing a lot of video?
Well, probably
Okay,
that.
I do a lot of video. I only have a 2 terabyte Mac. That's all that I need. Now, what you do is you make sure that you keep as many of your
External
files
drive.
on off storage.
Okay.
That's why I have 11 drives connected to my machine at home.
Holy cow.
That all?
I have a 2 terabyte Mac Mini, and then I have an SSD enclosure directly connected to it, Thunderbolt.
For
That's
backup?
4 more terabytes, and all of that is kind of working, and all of that's being backed up, the Time Machine, whatever backups. You know, all my big files of movies, I don't do as much as John does, but any video stuff I do, I have it all in the external drive, but it's because it's directly connected and fast connection, it's easy to
I don't
work on.
understand what you just said. Better connection, fast
So,
connection?
my external hard or
Mhm.
SSD storage is directly connected to the Mac Mini via Thunderbolt, which is the fast protocol for I/O. It's not USB, it's not FireWire, it's Thunderbolt.
Okay, I'll ask more questions about that on my,
So it's fast enough to support large files on an external device, but it performs as if it was all internal. I don't notice any lag or anything.
okay.
So
So,
yeah, unless you really need a large capacity internal storage while you're not at home, because that's what a
But then
laptop
I
would
could
be
just-
for portability,
right.
then
But then I could carry
Yeah,
a,
terabytes.
Yeah.
at least a,
Yeah,
I
a
could
little,
carry something.
That's what I
Another
did.
2 terabytes to
Yeah.
back up or
Sure.
whatever.
Absolutely.
Yeah.
Okay, let's move along.
Okay.
The other question.
Yeah, in photos.
Yeah.
How do you set up an album? It's on my phone.
Okay,
on your phone,
on your
my
phone?
on my
Oh.
phone.
you try mirroring to your own and see what happens, see how you, because I couldn't mirror to my own last month. I
John
could,
can.
but we're testing,
Right.
because I couldn't do this last.
It will not let me.
Isn't that bizarre? I haven't done it.
What was the question?
How do you create an album in Photos
Oh,
on your phone?
so
So,
you go to photos, that's where you start.
Yeah, he's in photos right now.
I'm in Photos right now. So let's say I want to put some images in an album. So first off, I'm gonna hit the select button at the top.
Which is,
It says select on it, top right.
but you're in the library,
I'm just in my
That's
library.
photo.
Yeah.
so you start at the library.
Yeah.
Okay.
I
Well,
mean, you
my
could start in another album, but then
No,
you're in
but
an
I'm
album.
just saying that sometimes I get up, and when I turn on photos, it doesn't come to the library, I don't know.
So at the
That's a
bottom?
different-
You might be
See at
looking
the
at
bottom?
something
I don't know
else.
what I'm looking at. So anyway, so you turn on things and then you go to, you click on library.
Yeah,
At
go to
the
the
bottom.
library if you're
Go to
not already
libraries.
a library. And
Okay.
then tap the select button.
Well,
Doesn't
What is
look
it,
like,
the 3 dots of select button?
no.
No.
It says select, right?
Okay, go to select.
Select. It doesn't look like anything really changes, except now you have an X, but at the bottom, it tells you, it's giving you instructions. Select items.
Right.
So you tap on it, and it gets a little check mark.
And then you go to select item.
And you can actually drag to select a bunch.
Mhm.
You can tap and drag.
Okay, then you just, so then you go to,
Once you have them selected, I mean, and you can scroll, and you can, whatever you need to do
so you select the pictures you want to put in now.
in the
Yes.
album. And then at the bottom left is share sheet. You tap that.
Wait a minute.
So it was the box with an arrow pointing
The
up.
box with the arrow pointing up is the share icon.
This one right down here.
Oh, yeah, okay, yeah,
So anywhere you see it in the interface,
right, yeah, I know.
doesn't
what
even
the
have to
share-
be
yeah.
photos. That means you're going to share something.
Mhm.
That's often where you're going to have to go to get any kind of menu about what you want to do. In here, there's add to album, and there's a plus sign.
Okay,
And it comes up, if you already have albums, you can choose an album to add them to. Or if you want a new album, there's a plus sign, top
Upper
right.
right hand corner.
okay, cool. There's a new one, plus for new, and that's it. And then.
No, you have to name it,
And then you can give it a name.
which is the hardest part of the whole thing.
Really?
I put more than space pictures in there, but it's okay.
Uh-huh.
And then you tap create,
Yeah,
and it takes you back to where you started in your library.
that's cool.
And then to see the album, you have to go to collections at the bottom, next to album, next to library. And then you go to albums, find the album thing, and then the most recent one will be at the top. Then if you don't want the picture in the album, you go to select while you're in the album, select those that aren't spaced, trash. And then,
But they're still in the original.
right,
Yes.
so when you remove from an album, it this point, you get a choice. You remove it from the album, which means they're still in your library, they're just not in this album. Or you can delete it here. Delete it. If
Yeah,
you hit
see how it's
delete,
red?
it's gonna warn you again, it's gonna give you another out, that if you go to delete, it's gonna actually take them out of your library too.
It puts it in a folder called delete, and it'll stay there for 30 days,
Right.
and then it'll delete it.
Yeah.
So you still can retrieve them if you delete it.
So if you're running out of space on your iPhone, go and check your delete folder and see how many thousands of pictures have not been deleted yet.
Oh my God, I hadn't thought of that. Can you delete a picture off of your phone still
No.
in the, up
If
in
you
the
delete it-
cloud?
If you delete it off of your phone, you just delete it on, if you have it set up to have icon storage, it will delete it on every single device.
Unless you have it backed up in Time Machine,
Yes.
and then you can retrieve it from there, but otherwise, no.
Well, with the phone, do you have a time machine?
If you
No.
back your phone up.
Yeah, if you have it turned on, which by default it is, it automatically backs up your phone, I forget how often, to the cloud, and you can go and retrieve it.
So that's what I'm saying. So you can just delete a picture from your iPhone, but it's still in the cloud,
Well, not conveniently so.
not convenient.
Yes, it's still a bad process.
So if you want to retrieve a deleted picture,
You
you
have
can
to,
go to Time Machine and get it.
no. If it's on your phone, what you have to do is restore your entire phone from the backup.
Which is in the cloud.
Yes,
Yeah, your iPhone.
and you're talking about a good hour, and it completely restores everything on the phone.
So,
But if you
even
back,
those other,
if you back up your phone to your computer,
okay,
they are in your computer.
Mm-hmm.
You can restore.
if I have a computer. that
Okay.
works. If I have a
Okay.
computer that works.
But the
Okay.
short answer is, no, you can't do what you want to do.
Yeah.
Okay, and I wish they had that feature,
Uh,
but it doesn't exist. Okay, any other questions?
It's break time. Woo! Let's take a 5-minute break, and then when we come back, we're going to start the feature presentation. Well, everyone, we're back from the break, and now, feature presentation. Magic of the Internet, or how to survive the digital age. Here is a simple visual of what the Internet does. You start off in your home with your computer. Information is sent to the router. The router sends the information to the Internet, which is the same thing as the cloud. The Internet and the cloud are synonymous from your point of view. So when someone says the cloud, don't freak out. It's just like a device.
A bunch of devices.
A bunch of devices out there. And then at the other end, the data is sent to a specific device to do something with. That device can be an email server, it can be a web server, it can be a storage device, but all that is happening is information is being sent out to a specific location. Most of you remember Surface Mail. What did you do in Surface Mail? You would write a letter, you would address it, you would give it to the postman would work their magic. How they did it, you didn't know, but it would end up at that addressee's location, at which time they would open it, take it out, and read it. That is exactly the way the Internet works. Exactly.
As long as there was a stamp on it.
But there's going to be another stamp here pretty soon. Okay, but the Internet's addresses are a little bit different. Any questions on the overview? Okay, you are now 10 times smarter than everybody else out there. Okay, this is what the Internet or the cloud does. It just sends data, addressed data. It has an address to know who this other guy is. It has to be a unique address. That many of you may have, years ago, about 10, 15 years ago, people were freaking out they were running out of Internet addresses. That has been solved. That now there is not an unlimited number of addresses, but there are so many addresses available now that we don't worry about it. Like, to give you an example, let's say you have 20 Internet devices in your home. To the Internet, it's all one address, not the individual addresses. They're all consolidated through that router so that the Internet thinks of it as just one address, not 20 devices. And how that works is magic. Any questions on this one? Am I over anybody's head yet? I'm ignoring you. Okay, let's talk about what happens inside your computer to make this magic work. You have an application that needs internet access. In order to get the address, the application contacts the communication software and goes out to something called a domain name server and says, hey, I have this person, give me its real internet address. A phone book. It's identical to a phone book. You all do remember phone books, right? Okay. The phone book, what you would do is you go into your phone book, find the person's name, and you get their phone number. The domain name server is identical. You give it a name, which can be an email address or a web server address. You know, the URL. It goes to the domain name server and says, what is this guy's actual street address? And gives it back to you. The software takes that, packages up the data, sends it down, packages up the data into packets to give to TCP/IP. Transmission Control Protocol is what it's called. This is the guy who sets up the virtual connection. He sends it out to the router. But actually what happens is a little bit different. TCP says, hey, internet, I need to talk to this address. Can you do it? He has no idea with anything else out there. And he gets a response back saying, yes, I can. Send me the data. And then TCP shoves the data down the line. He has no idea. As far as he's concerned, it's one connection. And remember back here when I showed you this one, this virtual, that it's setting up a connection, a pipe. It has no idea how it gets there. It doesn't care. All it knows is when you address your envelope, you put an address on it, you send it out, and you get something back. It does the same thing. It sets up a virtual. It looks like a solid pipeline. One connection. But in fact, it's not.
So it's like sending your letter to someone in LA, and from here it goes to Tucson, then to Dallas, then to Chicago, and then to LA.
Yeah.
Well, using the analogy, okay, and I'm going to explain this a bit. What really happens is they take the letter, give it to the post office. The post office cuts it up into little bitty pieces and sends each one of those pieces all over the world. And then eventually they get to Los Angeles where they glue it all back together and give it to you. As far as you're concerned, it's one piece. And that is exactly how it works. Below TCP is something else. And that's where the magic takes place. Okay. How does TCP find out its destination? TCP is the one who goes to the domain name server. You feed it. You say, hey, TCP, I want to send this information. This is the application talking. Now, the application is making calls to TCP, which is a separate entity on the machine. It's actual code that is made available to developers. And it says, here's the address I want to send it to, and this is how much information I want to send. So TCP says, okay, contacts the domain name server and says, give me IP address. That's what it's called. It's that funny, it's three numbers, 3.3.3.1.111.111.111.111. That's an IP address. Here is an email address, john@buono.us. His IP address is blip. TCP says fine, gets it, and then domain name server, and this is what a thing that most people don't understand. If the domain name server does not have an entry, it's not going to give you an IP address back. That's why, and the domain name server is not a single entity. It is a number of them. They keep each other informed of what's going on. So as long as you are registered, and that's what your ISP provider does, is make sure that your name is associated, let's say, with Cox. When you get a Cox account, your email address is registered with Cox so that all incoming traffic to you goes to the Cox server to come down to you. So that's what the domain name server, that's step one. Crucial step. And that's why sometimes you come back and it says unknown user. That means that that user doesn't exist. They don't know who he is. Yes, ma'am.
Or does it sometimes glitch and then you put it in again and then it finds it?
Yes. What happens then, and this is a little fuzzy even to me, you send your query out to your local domain server. It comes back and says, no, I don't know who that is. At that point, he starts contacting other domain name servers for updates to see if they have it. And then sometimes it'll just be the fact that it hadn't been registered yet. Or somebody gave you the wrong email address. Like we've got one member whose email address that we were given is wrong. Because every time I send them something, it bounces back saying, this guy doesn't exist. Or even worse, this network doesn't exist. Any questions on the domain name server? Okay. Your application browser asks the operating system to make a connection. It's calling up TCP. It gives it the IP address and the destination port. Now, it gets that from the domain name server also. There are specific ports. Now, these are virtual ports. It's like a socket. And there are certain sockets that are designed for certain types of information. Port 443 is specifically designed for HTTPS, your web server security. All information goes to that port because it's designed to handle that. Now, the fun starts. TCP adds the source and destination ports, adds sequence numbers as it's cutting up the information. Each packet of information has the originator IP address, which is not the one of your device. Okay, it's the one of your router, because a router is what everybody knows about. The sequence of the packet numbers, how many packets and which packet it is, it adds a reliability, a synchronization, and acknowledgement, so that when a packet of information is sent, it knows that it came back, but there's no IP address inside TCP, because TCP sends it down to IP, the Internet Protocol. Now, IP does is it adds the destination IP, adds time to live. Each packet has so much time in order to get to its destination. Now it becomes a complete packet. Now what happens is IP just starts sending packets out. And it says, hey, can you accept this packet? Talks to another computer. Can you accept it? Yeah, I know how to get to that address. Okay, I'll take it. And while it's doing that one, it goes to another computer and says, hey, can you send this one? Yeah, I can send that one. And all these packets go out to possibly completely different computers, depending on how many that network server up at Cox can talk to. How many lines does it have? And each packet goes out, and the IP at each of the different intermediate points is the same thing. Hey, can you accept this IP address? Yes or no? If it says yes, give it to me. If it says no, tries to find somebody else. This is worldwide. So the IP packets that you are sending out from that one application can travel all over the world. And sometimes what happens is a packet will get someplace and it comes back and says, no, I can't reach that guy. No, I can't reach that guy. And the time to live comes up and the packet. Well, at the destination, IP is taking all these packets and shoving it up to TCP. And TCP puts it back together. And all of a sudden TCP says, I'm missing a packet. I cannot successfully complete my mission of putting this back together. So it sends a non-acknowledgement back to your TCP. It says failed transmission. Or in most cases, the web page you're trying to load just doesn't load. That could be, yes. Or it just sits and spins and it never stops. That's why. Because somewhere along the line, something happened where a packet got mangled. And like it's called a checksum. If the packet comes in, there's a checksum number that goes with it. As to that number must match the checksum that runs to make sure the data is correct. So it runs this algorithm and says, oh, hold it, something's wrong. The checksums don't match. Sends a non-act back saying, we got a problem with this packet, resend that packet. And all this is going on at the speed of light. When you send a large file, we're talking about millions of packets going out. Because each packet is we have variable size packets now, but they're relatively small so they can go quickly.
How much data is in the packet?
I used to be able to answer that question easily. I believe 256. I believe that's what, but it's variable size now, and TCP can go out and change the size depending upon the quality of the transmission. And honestly, how that works is a sliding window. I've worked with it, but I don't honestly know how it figures out how big to make the window. Does everybody see what's going on now? Okay, let's go back to the post office, okay? You are sitting at your desk at your home. You are in your office, which is a room, okay? When you address your return address, do you use the address of your room or the address of the house? Right. That's what your router does. So you write the letter, you put it in the post office, postman, who's also TCP, picks up the letter, looks at the to address, and says, all right, how do I get, there's another guy in the post office, how do I get the letter with this address to that destination? Well, it goes and looks up in a directory, domain name server, saying, for this address, I need to send it to this other post office who will take care of delivering it. What's happening at the IP level is that IP is taking that letter, cutting it up into hundreds of little tiny pieces because it can go a lot faster. Each of them is addressed to anybody that can get to it. So let's say one goes to Tucson, one goes to Denver, one goes to Austin, Texas, one goes to Washington, D.C., whoever they're connected to. And each of them in turn say, how do I get this to that destination? And then keep going until they all come back together at Los Angeles where you're mailing it to, and the postman there starts going through and making sure that the size is correct. That's a checksum. The sequence, because they've all been numbered, puts them together, runs another checksum to see if it's correct, or if it determines that it's missing a packet, it goes back to who it believes is the originator, who is the originator, that post office, and says, to the TCP, to you, it says, I need this packet. It didn't come through. Send it again. And yes?
What's the advantage of cutting up, of sending all of these packets all over the world?
Speed.
As opposed to just sending them to the same place?
Speed and how much is on a particular line. If my truck is not here to go to Tucson, but I have a truck that's available to go to Denver, I'll send it to Denver to get it out and not waste time. So that's why they cut it up, is because there is so much traffic going on. It finds the best available path to get it there for each packet. Yes, sir.
I heard that the history of the internet was originally military-based, and that this whole design was such that if there was a message that had to go from DC to Boston, but New York or Philadelphia was taking it out, it could reroute itself and get to its destination.
Totally false. I'll tell you the true story, because I was there for it.
He's not that old.
Oh, yes, I am. Abe Lincoln and I were really good friends. The internet, as we know it, was put together by a military agency called ARPA, the Army Research and Development Program. But it was designed for educational institutes to communicate with each other working on DARPA projects. So it was educational institute because they needed to have a quick way of passing information, passing files, email, to get information quickly that wouldn't cost an arm and a leg. Back then, data paths were very short. University of California, Berkeley could talk to one or two other institutes. They could talk to others. So they developed a protocol so that it would be able to send stuff out quickly, get stuff back quickly, and not use up a lot of resources. It was never intended as a communication replacement for a military system. I worked on the one that did that, and it failed, but for other reasons. But that's the real reason the internet was done, why it was designed that way. Because back then, a high-speed line was a 9.6 modem. That was high speed. And they were experimental. It was never designed for the type of traffic that we got, nor the number of devices. That's why your IP addressing, it was actually limited, because they thought, I forget, it's in the millions, would be more than enough. Well, when the Army decided, and the Navy and Air Force, and everybody decided they wanted everybody in the DOD to have email addresses, that started to get a lot of people. Take a look at how many devices you have in your home that access the internet. I have 35, okay? So that's why the router, and we'll get to that in a second. So let's finish up with IP. Everybody understand how IP works now? And the reason it's done that way, there's a reason. It's not uncommon for a packet to get lost, or it reaches a destination and it can't get out. Or more commonly, not as bad as it used to be, the time to live dies. Now, we used to see that a lot when we had slow lines. With the high-speed lines of today, you rarely see the time to live actually transpire, because the time to live is in seconds. And you see how fast data comes back and forth. Just look at a web page. Yes, ma'am.
Does every device have a permanent IP address?
No. You get your IP address from your router, and then it's assigned to that. Now, you can get a new one. You can force it to give you a new one. As long as once you get that IP address, that is yours until there's a reason to get a new one. But that IP address
Comes from your router.
It comes from it's originally signed and then becomes part of that device. And when you go on another network, that address is taken and used to identify you. But like here at the college, if you send something out from here in the college, as long as you have an IP address, say, okay, you're good, logging you in. But when that goes out, it's the college address that it sees. Now, it gets a little bit more complicated than that. When you send something out, you go home in a different router, and it gets back in, because if you see what's in the TCP header, that you have the source port, the destination port, the sequence number, the acknowledgement number, and flags. And those flags are like for synchronization, acknowledgement. The IP header has a source IP address, the destination IP address, and the time to live, and a protocol that it's using. That protocol is almost exclusively now TCP. A few years back, there were plans on ditching TCP completely and going to a more robust protocol. Because of a lot of politics, that didn't happen. However, what's very interesting is that TCP today looks almost identical to what we were planning 20 years ago. So your destination IP address, your source IP address, when you move, it gets relogged in as to, hey, I'm here. So any traffic coming to this IP address should come to me. It's complicated. Like I said, the only reason this thing works is magic. If you get into the bowels of the protocol, you're saying, this works? Yes, ma'am.
So what's the difference between the source port and the source IP port?
Okay.
Or address.
The port is the plug that the data needs to be sent to. Each port has a specific responsibility. And it's like, post office boxes, that information for, if you wanted, advertisement goes in this box. If it's for personal letters, goes in this box. If it's photographs, goes in this box. That's a port. The IP address is the address of who it's for. The port is what's going to be done with it. Like 443 is for web browsers. So all information goes to 443, and that port knows what to do with it because it's different data. Okay, what happens on Wi-Fi versus Ethernet? We were talking about Ethernet. Wi-Fi uses radio waves, still carries IP packet. So you can put IP packets over the air, which is how the data here in Sierra Vista gets to Cox in Phoenix. You ever notice that sometimes the location that you get back, for instance, information says that you're in Phoenix, not Sierra Vista? Well, that's because the Cox relay is in Phoenix. So sometimes the location that the IP is carrying is in fact Phoenix, not Sierra Vista. And that's a screwed up problem. Ethernet uses cable, hard cable, but it's a special type of cable, and it goes much, much faster than radio. Is radio catching up? Well, yeah, but cable is still getting faster. I mean, cable using fiber optic, we're talking about millions of megabits per second. Wi-Fi, we're still talking about thousands. Gigabytes versus terabytes. Okay. Any questions on Wi-Fi versus Ethernet? Both will work.
If Wi-Fi uses radio waves, radio waves are easily disturbed by, atmospheric conditions and things like that. So why wouldn't that mess it up?
You're really showing your age. You're showing your age. That hasn't been a problem in years. Because the radio waves we use are at ultra high frequency. They're very short range, but there's very little that interferes with it. Now, can it be interfered with? You go inside of the building. You go inside my home. My home is a Faraday cage. Radio waves can't get through it. Jim Emmons and I had a big argument, and I told him, I said, come over to the house. Stand on my front porch. See if you can get to my Wi-Fi system. And in my back patio, because of the way I've set it up, I can actually get the signal. Yes, that is a consideration. That is why quite often you'll see cable still being used. Jim Emmons refuses to have Wi-Fi because what is the danger of Wi-Fi? People can capture the signal. So you have to consider that. That's why you always have it secured.
So Ethernet, no.
Ethernet, well, technically it is possible. You would probably notice some guy with a big toolbox in your living room. Okay, a good chance. Or digging up the cable in your front yard. They could say that they're going in and working on your septic tank, but if you don't have a septic tank, that doesn't work real well. I'm going to talk about, real quick, VPNs at this point. A lot of discussion this past week on VPNs. Virtual private network. The VPN's primary job is to protect data so it cannot be broken into until it gets to the VPN server that sends it out. So going from your home to the server and to a possible ultimate destination, it's locked. It also disguises your location. It can fool the network, because IP carries a location with it, into thinking you're someplace you're not. Now, why would people want to use this? Primarily Netflix. So you can go like to Great Britain and watch the Netflix in Great Britain that carries different content than Netflix in the United States. Or what I did when we were in Egypt is, instead of getting the Egyptian Amazon, I wanted the US Amazon. I had to go through a VPN. That's what the VPN does. That's all that it does. It protects your data for public networks. If you're in your own home, unless you're doing banking on a public network, you don't have to worry about it. Because once the data leaves your home, it's secured. If you're on a public unsecured network, like let's say you're in Starbucks and you want to check your bank account, you better use a VPN, because your passwords and logins can be easily captured on another device.
Or do it on your phone with data?
No, if you're Wi-Fi connected on a public network.
That's why I said data.
Now, if you're using like the LTE 5G or 5G ultra wide, you don't have to worry about it. That can't be captured. Wi-Fi can. So that's all VPNs do. VPNs are very easy to install. It's a little switch. After you install it, the switch says VPN on, VPN off. When you go to turn it on, it'll ask you, what location do you want to use? And most of them come back and say, hey, this is the best connection to use. And for here, it's generally Phoenix, sometimes Denver. Okay, let's move on. Yes, sir?
So where's the configuration of the VPN server relative to DNS? And, because you said there has to be an initial one to encrypt it and the other one to...
Okay, what the VPN does is the software on your phone, it contacts the VPN server and sends the data encrypted to it. And then it sends it out over TCP. But the data is completely encrypted. And then once it gets to the final VPN server, it decrypts it and sends it out over traditional lines.
So you go from router to VPN server to DNS.
No. Okay, you get the address prior to VPN. Software goes in and gets the IP address, and then when it goes down to IP, the VPN steps in and tells IP, use this address to send it to. It goes to the VPN server. It takes the information, opens it up, finds the destination IP address, and sends it out.
Oh, okay. So it overrides the default address that DNS normally had for a particular VPN server, such that it... Okay.
Yeah. It's using the VPN servers to encrypt the data. And then the last link is always over a closed network, not an open one. Yes?
Can you use a VPN on your phone?
Yes, absolutely.
Okay. And then do you usually have to have a subscription? I mean, how do you get your VPN?
It is a paid service.
But you can't.
There are free ones, but I wouldn't use the free.
The free ones I would not touch.
Yeah.
The best one I have found is NordVPN. NORD VPN. It's an application for the phone, both Android and iPhone. It's, I think, $50 a year, and it is excellent. You don't need... I've had it on and didn't even realize it. I forgot to turn it off on my phone and didn't notice any difference until something came back and said, I'm sorry, but I can't do this because you have your VPN turned on. And it's one of the applications that does a direct link. NAT does is it makes the internet, there's one address it's talking to, when in fact, there's all kinds of devices back there. And this is done by the NAT. Network Address Translation. The network is your home or office. The address is the IP address. And the translation is changing one address to another. So what it does is it takes your address, it gets to the NAT, it translates that into the address of your router. And that's what goes out. And then when it comes back in, it knows that, hey, this information is destined for this IP address. So it sends it back to you. Now, stop and think about that for a second. All that's going on, and it rarely does not work. So it's taking your information, keeping track of it, of the IP addresses, who it's for, type of information, puts it in there.
For that specific piece of hardware.
For that piece of hardware. Like in this room right here, the NAT for the college will take Barry's information, that IP address, store it, and it goes out. It looks like it's from the college. When it comes back in, it knows that, hey, this goes to Barry, or this goes to me, or it goes to you, or it goes to you. And it keeps track of that. almost simultaneous. So it's happening at the speed of light. And just think about all the things that are going on. And it works. I mean, to me, it's absolutely amazing.
A miracle.
Just short. We've gone over this 2 or 3 times about all the devices. And when you get home, start counting the number of devices in your home that actually connect to the internet. I've got a pressure cooker. I've got sous vide. I've got 2 televisions. I've got 3 computers, video game machines, iPods, iPads, iPhones, Apple TVs.
Door locked.
Pardon?
Door locked.
Oh, I forgot about my security system. Yes, absolutely. Motion sensors, light bulbs. I mean, the list of stuff is just gigantic. This is how that works. It just changes the address and puts stuff out. We've already talked about that. It's like an apartment building. The building address is your public IP. The apartment number is the private device. The front desk is the router, and the front desk forwards mail to the correct apartment. It's like a hotel. You send mail to the hotel, and the hotel looks up where you are and sends it to you. So the address you give is the hotel's address. Stuff is delivered. They look up your name to find out what room you're in and deliver it to your room. That's exactly what that does. So the internet is not that foreign, based upon how we live our lives. Putting it all together, DNS finds the IP address, the application gives the IP to the OS, and inside the OS, the operating system, TCP adds reliability, IP adds addressing. The router may rewrite it, and that's NAT, it generally does, and the packets travel across the internet. That's the fun part, okay, because TCP says, hey, Joe, I got stuff to give you. Joe answers back, okay, I'm ready. TCP says, okay, I'm sending it down to IP to make the delivery. IP says, ah, goes berserk. He says, how do I get all this stuff out? Starts throwing stuff all over the place to try and get it. Now, it is possible to all go over one connection. But if it can't, IP just starts throwing it out. And when it gets to Joe at the other end, Joe's IP starts putting it back together, hands it up to TCP. And as far as TCP is concerned, it's one connection. It has no idea what's going on at lower levels. And IP doesn't know nor care about how it gets there. It can go out over radio, it can go out over wire, it can go by donkey. Nobody knows. He doesn't care. All he knows is I'm sending it out to somebody who says they can handle it. Now we're going to talk about the web. We're going to get specific by 2 applications. Email, you type in a website address, the URL. The DNS is activated. The OS says, hey, DNS, this is the URL. Give me its IP address and socket. The browser then connects to a web server, which is that IP address. The server sends back a web page, and your browser displays it. So at this level, is that basically it's setting up a virtual connection as if you're directly connected to that web server. You send it a request, it sends you back information. You send it a request, it sends back information. You send it the URL, it brings you back the page associated with that URL. Now, when you get a 404, that means I sent it for a specific page. The web browser says, hold it. That page does not exist. 404 error. That's not an internet. That is a web browser error saying the page you are requesting does not, in fact, exist.
I mean, on the server.
On the server.
Server error.
It's a server error. Now, if it's a transmission error, what you'll see is spinning wheel of nothing coming back because somewhere along the line, the information got lost.
Is that buffering?
Pardon?
Is that buffering, when you see the buffering stuff?
Yeah. Okay, that means that it couldn't get to that server to get the page to come back and tell you it doesn't exist. If you get the 404 error, it means one of 2 things. Either A, you typed the URL wrong, or B, the site's messed up. They made a change. The page you're looking for no longer exists. It is not an internet. And I get a lot of people who think that it's an internet issue. No. It's a web server problem. So don't panic when you get the 404 error that your internet is not down, the internet's not messed up. It's a human error. Question? Okay, now let's talk about what a web server is. A web server is a computer. What type of computer? Yes. My Mac could be a web server. It has been. An iPad currently has no software to make it a web server that I'm aware of. You can use an Intel machine, you can use a Mac, you can use any computer out there can be made into a web server. In fact, for years, Apple actually had web server software on the Macs. And what it does...
They even once upon a time actually made server hardware too.
Yeah. And what this server does is it stores files and files and files and files of text material and images that are the web pages you see. So all that is being transmitted when you send your URL out, what comes back to you is text and the images. Most of them are highly compressed. They make them small. Standard port is 80 for HTTP, or HTTPS is port 443. Now, if you get a port error, that means that somewhere along the line, they have the wrong port. Like if you try and access HTTPS on port 80, you'll get a port error, and the other way around. So, but when it comes back to you, your web browser takes that text material, just ordinary text, and displays it the way the person wanted. And that's called HTML. It interprets the HTML into the letters, sizes, colors, all that. That's not sent as a page, it's sent as text material, which is the beauty of it. It's called page markup language. Hypertext page markup language, HTML. Okay. And hypertext, you know when you see the text with the blue line, that you can click on it? That's hyperlinks. What that does is it has an address in it. When you click on that, the whole thing starts over again. It goes and gets a specific page. What is a browser? Well, Chrome, Edge, Safari, Firefox, Chat Atlas, they're all browsers. What it does is basic.
Brave.
Yeah.
I haven't used Brave. First, it sends requests to servers. You give it what you want, and it's a URL, universal resource locator. It receives HTML files, and then it displays it. Now, video is sort of a special case. Generally speaking, what you see as a video is not brought down to your computer. It stays on the server and is played from the server. Because if some of these videos, if you were to try and download a full-length movie, it would be hours. But the data to display it is very small. So that's why you can have almost instantaneous watching on YouTube, because it's not downloading the entire video. It's just downloading the data to display it. Images, on the other hand, generally speaking, it will download the images, but not always. Sometimes it'll display it on the server. And you can tell the difference is if you click on an image and it delays in being displayed, that means it's downloading it. Because what it sent is it sent a small image, and then when you click on it to make it big, it's actually going and getting the larger image. If it's a delay. If there's no delay, then it's displaying it from the server.
And audio be the same as video?
Yeah, audio and video the same way. Audio recordings generally will stay on the server, but it depends on how big they are. What happens when you click a link? The browser sends an HTTP request, server processes the request, server sends back a response. The response is in a markup language called HTML. It's pure text with images. The browser displays the new page, interprets the HTML to display it. It's just like what you're doing is you input the first URL to get you that page. The hyperlinks already have it in there and it activates it. That's all that's happening. And it's kind of a marvel. Now, let's demystify the cloud. Everyone says, I don't understand the cloud. Well, there's no really, you don't have to understand it. It's not floating in the sky. It just means the cloud refers to someone else's computer. That's all that it is. It's somebody else's computer that's doing something that you want to have done. It could be an email server to handle email. It could be a web server to handle websites. It could be a storage facility. It could handle an application that is too resource intensive to be on your local computer. It's just another computer out there. Where? Who cares? It doesn't make any difference. You don't need to know its location. All you need to know is its service. And that's the beauty of the cloud. It's taken out you having to figure out where to go. It just does it for you. If you go up to a website, and like I go to the Adobe website to use one of their applications because it's way too resource intensive to have it on my computer. I give it what the video I want to have done. It brings it back to me doing what I wanted. Same with AI. AI is very resource intensive. So it uses the server in the cloud. Do I really care where it's at? No. Do I really care what hardware it is? Part of the danger is it, depending upon the sensitivity of your data, you may want to know. Like Chase. They have the Chase application, the Chase website. I know that's a secure website, okay? So I am comfortable with them having my data on it. Other places, not so much. Like I use a cloud backup system. I research Backblaze quite closely because they have access to all of my data.
You pay attention to what?
who they are. I researched the company to make sure they were a reliable company. The source is India, China, Pakistan, Sri Lanka. I'd be hesitant. Korea or Japan, reliable. Any questions about the cloud? Do you all feel comfortable about what the cloud is now? It's just another computer. That's all that it is.
So it's stored, like my photographs that are backed up to the cloud.
Yes.
Is stored on somebody else's server.
Yes.
Computer, but only one.
What do you mean only one?
Only one server somewhere.
Oh, no, there could be hundreds of servers.
Many.
But your photographs are on a specific server with Apple. It's just like you were backing it up to my Mac at the house. If I plugged your phone into my Mac, I could back it up. You're doing the same thing except over the internet with your photos.
But Apple has lots of servers,
Yeah.
not just one.
But as far as you're concerned, it is a server.
So this is like a big bunch of buildings that have
Yes.
computers
Yeah.
in it.
Yes.
There's thousands of computers.
That literally, it's like my little hard drive that I can carry around, only it's a really big bunch of hard drives.
Yes. Yes. You ever see in the movies where you walk in and they sit in the computer room and you see racks and racks and racks? Those are servers, okay? They're dedicated machines. They only have one purpose. And there's racks and racks and racks of them, but that's all it is. As far as you're concerned, it's one location. Sir?
With the Bitcoin deposits, the Bitcoin computer,
Yeah.
are they clouds also, or?
Yes. Yes. It uses the cloud. The
Probably have dedicated.
Yeah, they are dedicated. Bitcoin is a weird animal.
Anything to do with banking would probably be more specific.
Oh, yes.
Dedicated.
Yes.
Dedicated
Yes.
is the word used.
Definitely dedicated. Okay. Any other questions? 60-second recap. And I'm going to finish. Yes. Okay. You type a website name. You type your destination. Website, email, whatever. The DNS finds the IP address. TCP builds a reliable conversation. Hey, Joe, I got stuff for you. Hey, John, I'm ready. That's what TCP does. IP goes berserk. It hacks up everything, sends it out, puts it back together. The routers move packets step by step. They're the ones who take the information and make it go out as one. That's what your router does. That's its sole function, is that multiple connections seem as one. Your web server responds, your browser displays the page. It works the same for email. It's just a different address. When you have applications that use the internet, it's doing the same thing, except in this case, the address is built into it. It knows the address, so you don't have to do it. Like on your phone, do you have to put in like your banking app? Do you have to tell it chase.com with the app? No, it knows chase.com. It knows, like when you play these games that use the internet, you don't have to know the name of the server. You don't have to look up it. It knows it because it's been designed specifically for that. Like when you create with the icon of many applications, it knows the address, so you don't have to enter it. And in many cases now, it knows your name, your password, and like cookies. Something most people don't understand is that a web browser or the web server is strictly forbidden from accessing any information on your computer except for cookies that's stored with the web page. That is how it keeps information on you, like your name, sometimes your password that has been encoded. Last time you visited, that's what cookies do. Now, there's another type of cookies that are used for advertisement to keep track of what you look at, what your history. So cookies, if you're asked, and almost everybody asks now, will you accept cookies? Go in and take a look at what it's saving. If it's the personal information for that site, it's not going anywhere. Because what people were really afraid of when the web started first coming up is web servers would be able to access your computer. So now it's firewalled off. It cannot. It is strictly forbidden and it cannot do it. There's no way to do it. That was the problem with Gopher. Now, Gopher was a predecessor to web browsers. Barry, are you old enough to remember Gopher?
I remember it, but I never used it.
Okay. Gopher was a very primitive form of web browsing, designed by I want to say University of Michigan, but I don't know for sure anymore. Very clumsy user interface, but it could access your local computer, and that freaked a lot of people out. So that's why when web servers came along, it was decided no. The W3 committee said no access at all, except for the cookies file to make your life easier. Any questions? Yes, ma'am.
goes clear back to
Information, right?
password,
Yeah.
and passkey. Is that an Apple thing?
No,
That passkey is website related thing?
security related. It is you'll most often find them on websites. Wherever you have to log in using a login and password, a passkey can replace that.
And what is the passkey? Because I didn't make a password, I didn't give it anything, but it made a passkey.
Yes, it is a computational protocol that takes your information, scrambles it up, and stores it. So when it comes to a site to use the passkey, it takes your passkey, sends it to them, and they verify that that in fact is you. And then lets you in the site.
Device specific?
Yes,
Yeah.
very developed.
There's two
So
keys. There's two keys. There's a public key and a private key associated with your account. Your device sends the public key to the site. The site, okay, that's who that is, and then they send a message. Okay, I need you to confirm that that's who it is. And your private key on your device uses biometrics usually to confirm that you are who you are, and then it sends the message back saying yes, this is. But the site never sees your private key, so the actual encrypted key to get you in is never transmitted over the internet.
Now, Apple has done one thing, is that the passkeys are part of the Apple environment. So if you have a passkey on your phone, that passkey is available on your computer.
Oh.
You don't have to have two separate. That's not necessarily the truth for Windows or Android, but I do know for a fact on Apple, because of the way their architecture, that you can do that.
And many password managers will also.
So over everything up to date, passkey is the most secure.
Absolutely.
Because like your thumb can be grabbed. I'm sorry, that's gross, but
Yeah.
your thumb, your face, not so much. A number.
It's a little hard to tear the face off and put it
Yeah, right.
Yeah. I tried wearing a face one time, it just didn't work.
Yeah, okay. So the passkey conceptually to date is the most secure.
The only thing that's more secure than that is a hammer. You bust up the computer.
I've always been hesitant about biometrics because, when you set things up, you're fine, and then later on, you get sick. So if it was audio, now you got a cold, does it still know that it's you even though now you have a cold, you don't sound the same way when you first set it up? Or,
Yes.
Or, you did a facial recognition and, you started off with a beard, now you don't have it anymore. Or, I'm saying that when your biometrics change, how does it still know that you are you despite those changes?
Okay, let me explain that. The first on facial recognition, it uses 1,028 points on your face to identify you. Now, depending upon how much your face changed with a beard or without a beard, you may have to redo it. Your voice uses significant sampling. And so your voice would have to really, really have changed in order for it not to recognize it. Now, if you're using an eye scan, which not many personal computers use that yet, the retina scan, that is guaranteed. That can't change. Even if you have, cataract surgery, the retina blueprint is still the same. Your fingerprint, if you are a teacher back in the days of chalk, or you work construction sites around cement, you don't have fingerprints.
I don't have fingerprints.
Yep, she's the same way. And it's very difficult.
When I got my last fingerprint for teaching, I had to go to Phoenix to the FBI lab.
Yeah, they couldn't get mine when I worked at the police department because I did manual therapy 40 years and I probably just
Rubbed them off.
Rubbed them off,
Yeah.
yeah.
That's not uncommon. Yes, ma'am.
I got a new phone and it had facial recognition, and so, we did that. But it also wanted, like a 4-number
Yes, your passcode.
password, so that I can actually open my phone either with the 4 numbers
Yes.
or facial
Yes.
recognition.
Like it's
So-
backup.
Yes, but so how does that help as far as security?
Oh,
If you have anybody who we know, could figure out 4 numbers.
oh, it's supposed to be 6. It should be 6 numbers.
It should be 6 by default, and even that, you should go in and change it to go 8 or 9 numbers, or
Oh, I
do
didn't
an
even know
alphanumeric.
I didn't know you could do that.
Oh, yeah.
I thought it's
It
just
shouldn't be 4.
My phone is only 4.
mine's, yeah. well, I'm
But
just telling you.
I thought it used to be 4 by default,
Yeah.
but I thought they changed it to 6.
They did.
It's on a 7.
Well, no, well, when I, and this is a 17, so when I opened it up, when I started.
Yeah.
And it said, well, what's your PIN? I put in my PIN. It was 4 numbers.
You were migrating from an older phone, didn't you? Did you
probably,
have,
yes,
You had an
yes.
older, well,
That's
the
That
old
might
one
be
you
why.
had 4, so it would keep whatever you had before.
So you need to go in and change your passcode.
This
6.
is a new phone and it only has 4 digits.
But it'll let you
Which phone is
change.
it?
It's the
Ah, you can change.
16 Pro and it only asks for 4 digits when I set it up.
Go in and change it to 6.
So you can put as many numbers as you want. in
There are
it.
choices.
Yeah,
I think the most you can put in is 10.
How do you do
10 or
that?
12.
I think for
That's
numbers,
just
I think it
Under
might be 10.
passwords,
But you can also do an alphanumeric passcode, which just brings up the regular keyboard rather than just the numbers. And you can use letters and numbers. And that's what I hear is most likely, it's recommended for better security.
Yeah.
Because it's more random that
And you
way.
want 12,
I have a 9-digit,
You have a 9
and I programmed it in the alphanumeric keyboard, because I think, anyway, but I did keep all numbers, but I haven't.
Everyone take care, and we'll see you all next month. Have a great time.